So welcome.
Thank you. And thank you everyone for having me here today. So my name is Sofia Venturini, and I'm a PhD student at the Center for Psychedelic Research at Imperial College London. And I mostly work on neuroimaging and psychedelics. So today's talk is going to be a bit outside of the whole AI, computing, and these type of topics, but hopefully we can try to link into that as much as possible. So today's talk is going to be about psychedelics, creativity, and innovation. But before we can dive into the interesting part, I need you just to understand a little bit of background. So when I will be referring to psychedelics in this talk, I will be mostly talking about classic serotonergic psychedelics. What does it mean? Of course, it's just these psychedelics that act on the serotonergic system. So among these you have LSD, which is probably the most well-known one, psilocybin, the active ingredient of magic mushrooms. You have DMT, an active ingredient of ayahuasca, commonly used in cultural rituals and ceremonies. 5-MeO, secreted from this bufo. Mescaline, from this cactus. And then you also have MDMA, but it does sit a little bit more far apart pharmacologically. So for the sake of this talk, we're not going to consider that, and we will only be focusing on the classic serotonergic psychedelics. And as I was saying, what they have in common is that all the effects that they trigger, they are all mediated by activation of this serotonin 2A receptor. It's just a subtype of serotonin receptors. But if you block this receptor, then all the psychedelic experience just doesn't appear. So everything is mediated through that, including these beautiful visuals and hallucinations that you can get. But that's why also these substances are called hallucinogens. But the important thing is that they are much more than simple hallucinogens. And we actually understood that a very long time ago because they've been part of the human pharmacopoeia for more than 5,000 years by now. And they've been used in ritual ceremonies. Still now they are being used by indigenous cultures. And so when we then understood that again, we started doing research, and between the 50s and the 60s, there was a huge amount of research that was being conducted. The issue is that people got very excited, researchers in the first place, and these substances got out of the research settings and started being abused, and by the 70s, they became synonymous of counterculture and just got banned with the Controlled Substances Act, which actually classified these substances in the same schedule as cocaine or heroin, so all the substances that do not have any type of medical potential. So research just stopped. At the end of the 90s, though, we started getting into what we call this psychedelic renaissance. And it's just scientists in the UK, in the US, or even in Germany and Switzerland, actually, that started working again with these substances, and they really just opened the door for what we have now, which is an insane amount of high-quality research, an insane amount of funding, a lot of excitement. So it's a very exciting moment to be in this field by now. Enough with the background. Now let's get to the fun part. And today's topic is about creativity. And there's this story that I really like to talk about, and it's between psychedelics and genius. So I will try to tell it chronologically, but not only. So our story starts in biochemistry with Francis Crick, which is one of the scientists that actually deduced the double helix structure of the DNA. And there's this claim that he was under the influence of LSD when he had the insight of how the DNA was made. This is, however, a claim that surfaced years later, and of course, we can't really prove anything. But then the story continues in molecular biology with Kary Mullis, Nobel Prize for the PCR. PCR is the technology behind nearly all COVID tests that you took. And he publicly said that LSD had helped him conceive that machine. But what's the problem is that it's just on claims. It's nothing we can verify, nothing we can test. So I'm not really making a strong case now. But keep them in mind because they set the scene. And then the story continues into computing, and it's probably the part you may like a bit more. And during the 60s, there was this research foundation in Menlo Park, which is actually where the Silicon Valley now sits, that started running a bunch of people through LSD trials with actually the intent of understanding how psychedelics, LSD specifically, could influence creativity and problem solving. Very interestingly, one of the people that took part in these trials is Douglas Engelbart, He invented the computer mouse. And then, this goes all the way through people like Steve Jobs that actually wrote this in his biography, saying that LSD was one of the most meaningful and important experiences of his life. Sam Altman, Sergey Brin, Tom Ferris, even Elon Musk that came public about his ketamine treatment for his depression. Cat sits a little bit further away, so also now we're not really going to consider this, but it's just to show you that there seems to be quite a pattern. But again, it's just anecdotal evidence, and I'm not making at all a strong case, because just showing you successful people that use drugs, that's not a really scientific approach. But we start to see a pattern. And now we get to the part that I like the most, the evidence. Before we do that, I just need you to understand that creativity is not a single construct. It can be divided into divergent thinking, which is the capacity of generating many new ideas, and convergent thinking, the ability to pick the best solution out of a pool of ideas. So if you want, it's the difference between brainstorming and problem solving, very simply. And the way psychedelics affect each of these streams, it's very different. And the study I want to talk about here, it's a study that was conducted at Maastricht University, where they gave psilocybin to, if I'm not wrong, 60 people, and they measured different aspects of creativity. So they measured before they gave psilocybin, during the experience, and after the experience. And what they saw is that generally, during the experience, there was no change, or at worst, a reduction. So during the experience, people were less creative. But the interesting thing is that what they see is that 7 days after that experience, divergent thinking went up. So people were able to generate many more diverse ideas. But this already does contradict a little bit what was the claim about Francis Crick, that he had the insight of how the structure of the DNA was under the influence. Because if something, it might have been afterwards. And this is not only a one-timer, because the same research group found exactly the same thing a few years earlier, but with ayahuasca, and a little bit different trial design. So they had the placebo and an ayahuasca group, and they just measured, again, convergent and divergent thinking before and after. And the results confirm what we were just seeing. After ayahuasca, you see that divergent thinking, which is the last gray box there, is going up, especially in the ayahuasca group. And so we do see something, but it's very thin, and it's not what we may have expected, because it's only delayed, and it only affects one type of creativity. But if we know something is there, then the question that comes naturally is, why is it happening, and how is it happening? And so, how it happens, it's a little bit tricky, but I will try to keep it as conceptual as possible, so no hardcore neuroanatomy. But to understand that, you have to consider that in psychedelic science, there is this model called REBUS, Relaxed Beliefs Under Psychedelics. And to get it, you can think of your brain as a prediction machine. Your brain wants to be efficient, wants to be prepared for whatever is coming. And so to do that, we rely on priors, so just expectations and beliefs that we have about how the world works. And so in doing so, we see that we are incredibly rigid cognitively, because our previous experience is going to shape the way we experience anything in the future. And so what psychedelics seem to do is that they kind of relax those priors. They reduce the input from the brain on the experience itself. So if you get an input that is more unfiltered, you get novel combinations that can surface. Why? Just because your brain is being confronted with something it didn't know, or more information than what it was used to. And this is really what you see also in neuroimaging. This is the type of research that I'm involved in. But what you really see here is that in normal conditions, the brain works on very nicely and efficiently segregated networks. Each network can take part in a different function. With psychedelics, we see a complete shift in that, and the whole brain starts talking to each other much, much more. As you can see in the psilocybin image, parts of the brain that would normally not talk to each other start doing so. And that's why you end up having much more access to your brain. One single information doesn't become processed by a single brain region, but rather it gets taken into account collectively. And so, if we look at these mechanisms, we have reduced priors, reduced inhibition, and we have alterations in brain connectivity. So the mechanism for creativity is actually very much plausible. The only thing we have to take into account is that the studies that have been conducted are small sampled, very heterogeneous, so the evidence is relatively thin, but we do have something that may be there. But I will become a bit skeptical now, because I'm very skeptical about the single biggest claim in psychedelic science, which is microdosing. For those of you who don't know, microdosing consists in taking a sub-perceptual dose, so usually a tenth of a normal hallucinogenic dose, and you take that on a regime. Rather than taking it once, maybe for a week, you take it 3-4 times over an estimated period of time. But the problem with microdosing is that it seems to work very, very nicely when people self-report. All naturalistic studies that look into people that use that microdose on their own, they all report better health measures and psychological measures. The issue is that it's self-reported, so it's people who very much knew what they were taking and that, of course, just wanted it to work. So the question comes natural. Would this survive a placebo control? Would this survive in a clinical trial? Long story short, no, it doesn't. And what you see here, are the results from the largest microdosing trial ever done. And what they did is that they divided participants into a placebo group in blue, a microdose group in red, half and half in green. And what they saw is that, they took measures before, right after the microdosing regime, and 1 week after. And what they see is that all the groups improve in the same manner. There is no difference between each of these groups. So results are not holding. And another thing they measured is that they asked participants at the end of the trial if they could guess in which group they were being allocated. And the people in the microdosing group that understood they were being allocated to that are the ones that had the greatest improvements. So if the effects of the drug are driven by what you believe and what you expect, what is that? Clear placebo effect. There is nothing there. And these results have been replicated at Maastricht University and also at Imperial, where we recently finished a trial with a similar design, self-blinding participants, and there is nothing. So in one sense, it's not really skepticism, it's just showing you what the evidence is showing. And we don't really have any evidence that these psychedelics at that specific dose are doing what people claim they do. And so, to wrap this up, I will leave you with 3 very honest takeaways. The first is that we do see a creativity effect being there. There is something, but it's really much overstated because it's not acute, it's after the experience, and it only affects one type of creativity, which is divergent thinking. The famous stories are very nice, but a bit useless, to be honest, because they're just not causal proof. We cannot infer anything from that. But it's still very nice add-ons to have. And the last and most interesting is that we have a substrate for creativity that may actually be plausible. And it's really worth studying a little bit more. So microdosing doesn't really seem to be doing anything, but I think this is a bit of a brain teaser. And the question here would be, if we understand the mechanisms of creativity, could this be modeled? And if they can be modeled, could we build AI tools that replicate these mechanisms? Because what AI does is that in terms of creativity, it regresses everyone towards the same statistical mean. So in other words, everyone is pulled towards the same ideas. Psychedelics do exactly the opposite. They push outwards. They kind of force people to make their own independent association. So genuinely interesting to understand whether there could be a bridge on these lines. And so I have to be honest that this is not my sentence, but I found it very nice, so I chose to have it. So we're not really hacking the mind yet, but we may actually be starting to understand its source code. And what these tools may actually be doing, they will probably tell us less about how to consume these substances safely for ourselves, but maybe they can actually teach us how to build really creative machines, how to actually boost our creativity through something else. So these are my references. Thank you very much.
Thank you, Sofia.
Just a quick question. So you basically told us that microdosing may not work. What about macrodosing? Because I've seen around, and now there are people doing like big ass 5-gram psilocybin trips. Do you have any factoids about that?
Actually, the first evidence. The first evidence I was showing was actually from macrodoses. I should have mentioned that. But yeah, usually the studies are done not with these huge doses that you're mentioning, but with medium to nearly high doses, but nothing huge. And I mean, this is what we're seeing. You do see something happening in terms of creativity. Other aspects include cognitive flexibility, so people kind of get out their very rigid thinking schemes. And that's also something that can contribute, but this is mostly with high doses, or like real doses.
So you don't recommend or go home with?
What, sorry?
You do not recommend go big or go home with?
Yeah, absolutely, yes.
You do recommend
Go
it?
big or go home, yes.
Oh, yeah, okay, cool.
It's the evidence saying it, not me. Microdosing just doesn't work. If you actually want to take it and really believe in it, placebo effect is a real thing. That's why in clinical trials we test drugs against that, because it actually does something. We do see improvement in patients. But it's a placebo effect. Like it doesn't work in practice. We don't have any evidence that the molecule does something at that dose. Thank you. Thank you,